Hello, to join Marine Gurukul Online Academy for online support to pass your certificate of competency, kindly get in touch with us. Mail to us your queries on marinegurukul@gmail.com. Hello, welcome to Marine Gurukul video series. In this video, we shall understand and learn to describe a few terms in context of International Road Line Convention 1966. Bulkhead deck. Bulkhead deck is the uppermost deck to which transverse watertight bulkheads are carried. So please remember, the uppermost deck to which transverse watertight bulkheads are carried is called as the bulkhead deck. In most cases, we may have a scenario like this which can be seen in the diagram. All the transverse bulkheads are carried to the same uppermost deck. In such a case, this uppermost deck, which is continuous from one end of the ship to the other, is the bulkhead deck and is referred to as continuous bulkhead deck. In some other cases, as can be seen in the diagram that has just come up on the screen, we may have the transverse bulkheads terminating to a higher deck in some parts, and in the others they may be terminating at a lower deck. In such cases, subject to certain conditions, of course, the bulkhead deck shall be split, and as you can see in the diagram, the red decks represent the bulkhead deck in their respective zones. So for zone A, B, C, G and H, deck 1 shall be the bulkhead deck, while for D, E and F, deck 2 shall be taken as the bulkhead deck. As I have already said, of course, there are certain conditions connected to it. So this deck 1 and deck 2 respectively being taken as bulkhead deck shall be subject to those conditions. Margin line. Margin line is a line drawn not less than 76 mm below the upper surface of the bulkhead deck at the side of the ship. Now this is minimum 76 mm. Please remember, if a ship owner wants it to be more than 76 mm, it's perfectly in order. Now if the bulkhead deck of a ship is continuous, as you can see in this case, then the margin line shall be at a distance of not less than 76 mm below this continuous bulkhead deck. So in this case, the margin line shall also be continuous, as can be seen by the green broken line in the diagram. However, in cases where the bulkhead deck is not continuous, the margin line should be assumed with reference to the deck to which bulkheads concerned are carried, and in this case the margin line shall not be continuous. In some parts it will be marked with respect to deck 1. In the remaining parts, as you can see, it shall be marked with respect to deck 2. Why are we talking about margin line? Now vessel forms a watertight chamber with the keel at the bottom, shell plating on the sides and the bulkhead deck on top. So in the vertically upward direction, bulkhead deck represents the level to which the vessel forms a watertight chamber which could be displacing water to generate buoyancy. However, margin line is what is used to define the highest permissible location on the ship side of any damaged water plane in the final condition of sinkage, trim and heel. Why? Because you do not want to go down in the water right up to your bulkhead deck. So margin line defines the highest permissible location on the ship side of any damaged water plane in the final condition of sinkage, trim and heel. To ensure adequate safety of vessel after flooding, it is necessary that no part of the bulkhead deck be submerged after flooding. Why? Because the watertight chamber is up to the bulkhead deck. If the bulkhead deck submerges, then openings on top of the bulkhead deck which are not watertight may submerge and lead to progressive flooding. So the final limit to which the vessel can be submerged without risking it is the bulkhead deck. However, allowing a margin of safety of 3 inches, which translates to 76 mm, a margin line is drawn, and it is drawn at a distance of not less than 76 mm below the bulkhead deck. And to ensure that you have this 76 mm of safety margin up your sleeve, in any condition of flooding, this margin line is not to be submerged. Length as defined in the load line convention. Length shall be the greater of the options that follow. So there are two options. The greater of the two shall be taken as the length, and both of them measured at what level? They are both measured along the water line at a draft equal to 85% of the molded depth. So length is the greater of the following, all measured along the water line at 85% of the least molded depth. One option, 96% of the total length along the water line at that particular draft. Two, the length from where the water line intersects the fore side of the stem, and this is your forward perpendicular, to the axis of the rudder stalk, that is your after perpendicular. So the second option translates into LBP. You can see this in this diagram. Now here, this level represents 85% of the molded depth. We can have the water line at this draft. WL represents the total length of the water line at 85% of the molded depth. Now 96% of WL shall be the first option. And then we have the forward perpendicular here. We have the after perpendicular here. Our second option will be LBP. And the greater of the two, which one? 96% of WL in this diagram or LBP. The greater of these two shall be the length of the vessel. Breadth. Breadth is the maximum breadth of the ship measured amidships. So it has to be measured amidships, midway between the two perpendiculars. The molded line of the frame in a ship with metal shell. That means ships with metal hull, the breadth shall be molded breadth. That means measured from inside of the shell plating to inside of the shell plating. That means the thickness of the shell plating shall not be taken into consideration. The outer surface of the hull in a ship with shell of any other material. So if the shell is not a metallic shell, that means the hull of the ship is not of metal, then in that case it shall be the extreme breadth from outside of the shell plating to the outside of the shell plating. As you can see in this cross-sectional view at amidships, from metal ship you can see the breadth is the molded breadth, and for ship of hull of any other material than metal, it is the extreme breadth. Molded depth. Molded depth is the vertical distance measured from the top of the keel plate to the top of the freeboard deck beam at the side of the ship. So it's measured on the sides of the ship. Now please pay attention, it's not top of the freeboard deck, it's top of the freeboard deck beam. So that means, which is the same as the underside of the deck plating. Which means in molded depth, the thickness of the keel plating and the thickness of the deck plating shall not be included. As you can see in this diagram, we have red lines representing the top of the keel plate and the top of the freeboard deck beam or the underside of the deck plating on the side, and the vertical distance between them is the molded depth. In ships having rounded gunwales, the molded depth shall be measured at the point of intersection of the molded lines. Pay attention to the word molded lines of the deck and the shell plating. The lines extending as though the gunwale were of angular design. So if we have this case here where we have the deck and the shell plating and rounded gunwale, this is the molded line of the deck. That means a line drawn in line with the underside or lower edge of the deck plating. This is the molded line of the shell plating drawn in line with the inner side of the shell plating. Both of them intersect here. This is the point from where the molded depth shall be measured up to the top of the keel plating. So in this case, the molded depth shall be measured from this level and it will go up to the top of the keel plating. Depth for freeboard. Depth for freeboard is the molded depth amidships, which we just discussed, plus the thickness of the freeboard deck stringer plate if fitted, plus a correction for the sheathing if the freeboard deck has sheathing. So that means to the molded depth amidships, we add the thickness of the deck plating on the side, plus if there is sheathing of the freeboard deck, a certain correction is also added to allow for the sheathing. What is sheathing? Sheathing is like having a wooden flooring done on the deck. Sheathing is a protection for the main deck of the vessel as pine boards about 1 inch in thickness laid over the deck. As you can see in this diagram, here we have the sheathing of the deck. If there is sheathing of the deck, then the correction for the sheathing shall be calculated by this formula. In this formula, T is the thickness, mean thickness of the sheathing. L is the length of the vessel already defined. And S is the total length of the superstructure, which we shall soon be defining. So, depth for freeboard is nothing but molded depth amidships plus the depth of the freeboard deck stringer plate plus the correction for sheathing if the freeboard deck is sheathed. Block coefficient CB shall be calculated by the following formula. CB is equal to volume of displacement at draft D divided by length into breadth into draft D. What is D here? D is the draft equal to 85% of the molded depth, and molded depth has already been defined. What is length? Length is as defined earlier, and so is capital B, the breadth as defined earlier. So in all the load line calculations, wherever block coefficient is to be used, it shall be used as calculated by this formula. However, in no case the block coefficient is to be taken less than 0.68. So if the calculated block coefficient happens to be less than 0.68, then the calculated block coefficient shall not be used. Instead of that, the minimum value of 0.68 shall be used. Freeboard. Freeboard assigned is the vertical distance measured from the upper edge of the deck line to the upper edge of the related load line. For example, in this case, if we are talking of summer freeboard, then it shall be the distance measured from the upper edge of the deck line, which is the reference line, to the upper edge of the summer load line mark, and this distance shall be the summer freeboard. Likewise, if tropical freeboard is to be measured, it shall be measured from the top of the deck line to the top of the tropical load line mark, and that shall be called as tropical freeboard. Freeboard deck. Freeboard deck is normally the uppermost continuous deck exposed to weather and sea, which has permanent means of closing all the openings in the weather part thereof. That means all the openings in the weather part of the freeboard deck must have permanent means of closing them. And below the freeboard deck, all the openings in the side of the ship are fitted with permanent means of watertight closing. So all the openings below the freeboard deck must have means of closing them watertight. In a ship having a discontinuous freeboard deck, the lowest line of the exposed deck and the continuation of that line parallel to the upper part of the deck is taken as freeboard deck. For example, in this diagram, we have discontinuous freeboard deck where the discontinuity is more than 1 meter. In such a case, the freeboard deck shall be in line with the lowest line of the exposed deck, this line out here. So the freeboard deck shall be here, and this shall be the reference for measuring the molded depth. Likewise, in some cases, we may have a freeboard deck, which is one of the lower enclosed decks, and in that case, the freeboard deck again would be the reference for measuring the molded depth. Minimum bow height. Minimum bow height is defined as the vertical distance at the forward perpendicular between the waterline of the vessel at assigned summer freeboard and the top of the exposed deck at the side shell, and at the vessel's design trim. So what is minimum bow height? A, it's measured where? At the forward perpendicular. Between which points? One is the waterline at assigned summer freeboard, that means summer waterline of the ship. 2, the top of the exposed deck on the side of the shell and at the vessel's design trim. Minimum allowable bow height must be maintained when a vessel is floating to her summer load line at its design trim. The assigned summer freeboard for a vessel must be increased if necessary to ensure that minimum bow height requirements are met. So, if the construction of the vessel is not able to provide the required minimum height applicable to that ship, then her assigned summer freeboard must be increased so that the minimum bow height requirements are complied with. The minimum bow height required in millimeters HB is calculated by formulae which are function of the length of the ship and her block coefficient, and the formulae are different. One formula is for ships of less than 250 meters in length, and we have another formula for ships of 250 meters or more in length. Both the formulae are on display on the screen. They are function of ship's length and block coefficient CB. And as already said in the definition of block coefficient, if the calculated block coefficient of the vessel is less than 0.68, then the block coefficient to be used is minimum 0.68. The minimum bow height during ship construction may be achieved by either fitting a raised forecastle deck, provided that such a forecastle extends over at least 7% of the ship's length from the forward perpendicular. So you can see in this diagram, if the minimum bow height is to be measured up to the upper edge of the forecastle deck, in that case, the minimum length of the forecastle has to be 7% of the ship's length. So it has to be 7% or greater. Measured from where? Forward perpendicular. Or by including shear, provided the shear extends over at least 15% of the ship's length from forward perpendicular. So in lieu of forecastle, if shear is provided and the shear is to count or contribute towards minimum bow height, then the length of the shear, or the length over which the shear extends, should be minimum of 15% of the ship's length. Well, the bulwarks on the weather portion of the freeboard deck or the superstructure decks form the wells for entrapment of the ship's seas. Now we're talking of ships where you may have bulwarks on the exposed decks instead of railings. So when you have the bulwarks and you have the seas which ship on the decks, then these bulwarks act like the walls on the side, and the water gets entrapped as the water is there in the wells, because it takes time for the water to drain from the deck. As this entrapped water adds to the displacement of the vessel until it is drained, ample provision shall be made for rapidly freeing of the decks of water and draining them. So there has to be ample provision for draining them rapidly, otherwise it's as if extra weight has been added onto the ship. On flush deck ships with substantial deck house amidships. Now we have spoken about a deck which does not have any superstructure, so it has only the bulwarks. But if you have the superstructures in between, so if you have substantial deck houses amidships, then it can divide the full deck, exposed deck, into two parts or multiple parts. It is considered that the deck house provides sufficient break to form two wells or multiple wells, and that each then such portion or each such well requires to be considered separately for ensuring that each one of them has sufficient freeing port area. That means sufficient provision for freeing of the entrapped water depending on the length of the well. Superstructure. Superstructure is a deck structure on the freeboard deck. So it's a structure above the freeboard deck, and the structure itself has its own deck. So it's a decked structure above the freeboard deck, extending from side to side, that means full breadth of the ship, or with the side plating not being inboard of the side of the ship by more than 4% of the breadth. So if we see in this side elevation, we have the freeboard deck, then we have the raised forecastle, we have the raised poop, and we have a structure amidships, raised structure amidships. Now these three decked structures above the freeboard deck, for them to be called as superstructure, they must extend from side to side, either from side to side, or for example, if the structure amidships is not extending from side to side, then it must not be set inboards by more than 4% of the breadth. If it is set in by more than this margin, it shall fail to be qualifying as superstructure. Raised quarter deck is regarded as a superstructure, and this diagram shows us what is meant by raised quarter deck. We had just defined what a superstructure means. Now every superstructure may meet the certain minimum height criteria, and then it shall be called as a standard height superstructure or a superstructure of standard height. If it is failing to meet that minimum height criteria, then it shall just be a superstructure but not meeting the standard height requirements. Standard height of a superstructure shall be as per the table given in Regulation 33 of Load Line Convention. The table gives the standard height based on the length of the ship, and the standard height for raised quarter deck and other superstructures are different. For a ship of 30 meters or less in length, the standard height requirement for raised quarter deck is 0.9 meters. For other superstructures, it's 1.8 meters. For 75-meter long ship, it's 1.2 and 1.8. For A ship of 125 meters or more in length, it's 1.8 and 2.3 meters. For ships of intermediate lengths, that means between 30 and 75 or 75 and 125, the standard height of the superstructure can be calculated by linear interpolation. And if a superstructure is meeting the standard height requirement, it shall be referred to as superstructure of standard height. Enclosed superstructure. An enclosed superstructure is a superstructure with enclosing bulkheads of efficient construction. Excess openings, if any, in these bulkheads are fitted with doors of material and strength so that the whole structure is of equivalent strength to the unpierced bulkhead and weathertight when closed. All other openings in the sides or ends of the superstructure are fitted with efficient weathertight means of closing. A bridge or poop shall not be regarded as enclosed unless access is provided for the crew to reach machinery and other working spaces inside these superstructures by alternate means which are always available when bulkhead openings are closed. So, for a superstructure to be enclosed, firstly it should be a superstructure. 2. It should be enclosed by bulkheads of efficient construction. If access is to be provided through the bulkheads, they must be fitted with weathertight doors of adequate strength so that when the doors are closed, the full bulkhead retains the same strength as if it was unpierced. All other openings on those bulkheads should have weathertight means of closing. And a bridge or a poop where the crew needs access, they shall not be regarded as enclosed unless alternative means of reaching these spaces are provided when the bulkhead openings are closed. And if all these requirements are fulfilled, the superstructure shall be referred to as enclosed superstructure. Effective length of superstructure. Effective length of superstructure is the length which is taken into consideration to compute the reduction in freeboard. In other words, the load line convention is interested or takes into account the effective length of superstructure. Effective length of superstructure is computed as follows. Except as provided in the paragraphs that follow, few exceptions that follow, the effective length represented by capital E of an enclosed superstructure of standard height shall be its length. That means if we have an enclosed superstructure of standard height, then unless it comes into exceptions that follow, in the absence of exceptions, its actual length shall be taken as effective length. However, if the enclosed superstructure of standard height is not extending from side to side but set in from the ship side as permitted, and what is the maximum set in permitted, guys? It shall not be set in by more than 4% of the breadth. So when an enclosed superstructure of standard height is set in from the sides of a ship as permitted, the effective length shall be the length modified by the ratio small b by capital BS, where small b is the breadth of the superstructure at the middle of its length and BS is the breadth of the ship at the middle of the superstructure. So whatever is the length of this enclosed superstructure of standard height which is set in, whatever is its actual length, that actual length will be multiplied by the ratio of small b by bs, and whatever is the outcome, that will be the number that will be counted towards the effective length of such a superstructure. So in such a case where the superstructure is set in from the ship side, the effective length shall not be the actual length, it shall be less than that, and it shall be reduced in the ratio of breadth of the superstructure to the breadth of the ship measured at the middle of the superstructure. Where the height of an enclosed superstructure is less than the standard height. So you have an enclosed superstructure, but it's not meeting the criteria of standard height, it's falling short of it. In such a case, the effective length shall be the length of superstructure reduced in the ratio of actual height to standard height. So that means whatever is the length of such superstructure, it shall be multiplied by the ratio of actual height to standard height, and whatever is the outcome, that shall be the effective length, implying in this case also the effective length shall be less than the actual length of such a superstructure. Where the height exceeds the standard height, no increase shall be made to the effective length of superstructure. So no benefit for height of an enclosed superstructure being greater than the standard height. The effective length of a raised quarterdeck, if fitted with intact front bulkhead, shall be its length up to a maximum of 0.6 L. So if a raised quarterdeck, if you remember, raised quarterdecks had the requirement of lesser standard height. So if a raised quarterdeck is fitted with an intact front bulkhead, then its total length can be counted towards the superstructure, effective length of the superstructure, provided this number does not exceed 60% of the ship's length. Where the bulkhead is not intact, the raised quarterdeck shall be treated as a poop of less than standard height, and when we have a superstructure of height less than the standard height, we know how its effective length is to be computed. Superstructures which are not enclosed shall have no effective length. Trunk. A trunk is a structure like a superstructure. That means it's above the freeboard deck, has its own deck, so it's a decked structure above the freeboard deck, but failing to qualify on the width criteria. That means it's set in by more than 4% of the breadth. A trunk or similar structure which does not extend to the sides of the ship shall be regarded as efficient on the following conditions. The trunk is at least as strong as a superstructure, so its strength should not be less than the strength of the superstructure. The hatchways are in the trunk deck, and the hatchway coaming and the covers comply with the applicable requirements. The breadth of the trunk is at least 60% of the breadth of the ship. So it may have been set in by more than 4% of the breadth, never mind, but its breadth should not be less than 60% of the breadth of the ship. Where there is no superstructure, the length of the trunk is at least 60% of the ship's length. So if a structure similar to superstructure, failing to qualify as a superstructure because of the breadth, but is meeting all these requirements which are listed here on strength, on requirements of strength of the coaming, its hatchway, the breadth and the length. If all these conditions are fulfilled, then this structure is called as a trunk. Effective length of trunk. The full length of an efficient trunk, and we just learned what an efficient trunk means. So the full length of an efficient trunk reduced in the ratio of its mean breadth to the breadth of the ship shall be its effective length. Of course, subject to standard height. What does it mean? It means the length of the trunk multiplied by ratio of its mean breadth to the breadth of the ship shall be its effective length. In other words, the effective length shall be less than its actual length, and of course, subject to meeting the standard height criteria. Standard height of a trunk is the standard height of a superstructure other than the raised quarterdeck. If you remember, based on the length of the ship, we had some standard height requirement for raised quarterdeck and a different standard height requirement for other superstructure decks. Whatever is the standard height requirement for other superstructure decks, same shall be the standard height for the trunk. Where the height of the trunk is less than the standard height, its effective length shall be reduced in the ratio of actual height to standard height. So that means, firstly, the actual length of the trunk shall be reduced for its breadth, and then if it's failing on the standard height criteria, it shall be further reduced for height. Hatch comics that have heights equivalent to or that of the standard height of the superstructure as determined by the table in the convention may be considered as trunks that provide additional reserve buoyancy to the ship. So hatch coamings subject to meeting the requirements could be a good example of a trunk. Shear. Shear is defined as being the curvature of the freeboard deck in fore and aft direction. As we can see in this diagram, the freeboard deck is curving upwards at the two ends. And at the two perpendiculars, the measure of the curvature, like in this case, this is the measure of the shear forward, and likewise, we have the measure of shear aft. Benefits of shear include shear forward increases the bow height, greater reserve buoyancy at the ends of the ship, particularly forward, ensuring good lift in head and following seas, reduces the water that is shipped on deck, and reduces the risk of foredeck being submerged after collision, thus improving the survivability in the damaged condition. Type A and Type B ships. Type A ship is the one which is designed to carry only liquid cargoes in bulk and in which cargo tanks have only small excess openings closed by watertight gasketed covers of steel or equivalent material. So what ships are we talking about? Primarily we are talking of tankers which carry liquid cargo in bulk, openings which we call as tank domes. Tank domes have watertight or oil-tight gasketed covers of steel or equivalent material. Such a ship necessarily has high integrity of the exposed deck. Why? Because of the small excess openings on deck to the cargo tanks compared to large hatchway openings in dry cargo ships. High degree of safety against flooding resulting from low permeability of loaded cargo in the spaces and higher degree of subdivision. Such ships usually have one or two longitudinal bulkheads as well. So they have a higher degree of subdivision, and the liquid in the tank fills up the space completely, and therefore the permeability of in the loaded condition of the cargo spaces is relatively much lower than the dry cargo ships where you have broken stowage. Type B ships is any ship other than Type A ship. So if a ship does not qualify to be a Type A ship, by default it becomes type B ship. Position 1 and position 2. For the purpose of load line regulations, two positions of hatchways, doorways and ventilators are defined. Position 1 is upon exposed freeboard deck. So whichever portions of the freeboard deck are exposed to sea, those will all be taken as position 1. And on the superstructure decks, which include the raised quarter deck, the superstructure decks situated forward of a point located 1/4 or 25% of the ship's length from the forward perpendicular, that particular stretch of 25% of the length from forward perpendicular on the superstructure deck shall be taken as position 1. So if we look at this diagram, in this we have 3 superstructures. So there are 2 parts on the freeboard deck which are exposed, which are being shown by the red line, and both these positions here on the exposed freeboard deck and here on the freeboard deck are positions 1. And on the superstructure decks, 25% of the length from forward perpendicular, which is now coming up, this part of the superstructure deck here represents position 1. What is position 2? The other parts exposed to weather, other decks exposed to weather, will be position 2, is upon exposed superstructure decks situated abaft of 25% of the ship's length from forward perpendicular. So in this diagram, the decks being marked in green, they are all position 2. What do you see from this diagram? That position 1 are the positions which are more severely exposed to sea. Relatively, position 2 is better protected than position 1. We may have another case of a ship, in which case we have freeboard deck. We have the freeboard deck is fully covered by a superstructure deck. So now there is no part of the freeboard deck which is exposed. On the superstructure deck, the forward 25% of it shall be position 1, you can see, and the remaining would be position 2. We could take another example where we have freeboard deck covered by a superstructure deck, and this superstructure deck is further covered by another superstructure deck at the forward end. So now in this case, what happens? There is no part of the freeboard deck which is exposed. Then we have the superstructure deck, of which 25% should be position 1, but that is also covered by another superstructure deck. So that is also protected. So in this third case, there is no part which is position 1. Entire deck is position 2. Why? Because the forward 25% of the length on the first superstructure deck is further protected by the second superstructure deck. Now, why is this position 1 and 2 critical is because depending on whether these hatchways, doorways or ventilators, if they are located in position 1, then they need to be meeting more stringent requirements compared to what if they are located in position 2. Why? Because position 1 is more exposed to sea compared to position 2. And that is what is position 1 and 2. Now we come to end of this video. Hope you found this video useful. If so, kindly share with your friends, subscribe to the channel, like the video, share your comments, so that keeps us motivated and we make more videos that can be of use to our community. Thank you very much for watching Marine Gurukul video series. All the best.